They are the two largest and most powerful constrictor snakes on Earth. Both can exceed 7 meters in length. Both kill not with venom, but with sheer muscular force, coiling around prey and squeezing until the heart can no longer beat. Both have become symbols of primal fear and fascination in human culture, appearing in countless films, myths, and nightmares. And yet, despite this striking similarity in size, hunting method, and reputation, the anaconda and the python are separated by an entire ocean. Quite literally. They belong to two completely different snake families that evolved independently on two different continents, tens of millions of years apart, arriving at remarkably similar solutions to the same evolutionary challenge: how to become the apex constrictor of your ecosystem. Today, WildForge explores everything that separates these two giants of the serpent world, their ancient origins, their physical differences, their hunting strategies, their reproductive biology, and the genuine question that has fascinated herpetologists for generations: which of these two extraordinary snakes truly deserves the title of the world's largest snake? This is where the story becomes immediately more complex than most people realize, because anacondas and pythons are not simply two species. They are two entirely separate families, each containing multiple distinct species. Anacondas belong to the genus Eunectes, within the family Boidae, the boa family. This places anacondas in the same broader family as boa constrictors, with which they share a closer evolutionary relationship than with any python. There are 4 recognized species of anaconda: the green anaconda, Eunectes murinus, which is by far the largest and most well-known; the yellow anaconda, the dark-spotted anaconda, and the Bolivian anaconda. All 4 species are found exclusively in South America, primarily across the vast wetland systems of the Amazon basin, the Orinoco River system, and the Pantanal, the world's largest tropical wetland. Pythons belong to an entirely separate family altogether, Pythonidae, which contains roughly 40 recognized species spread across Africa, Asia, and Australia. The largest and most relevant species for this comparison is the reticulated python, Malayo-Python reticulatus, native to Southeast Asia, which holds the record for the longest snake species on the planet. Other notable python species include the Burmese python, the African rock python, and the Indian python. Crucially, boas and pythons diverged from a common ancestor an estimated 50 to 60 million years ago. Despite this deep evolutionary split, both lineages independently evolved the same core survival strategy: powerful heavy bodies built for constriction, heat-sensing pits in some species to detect warm-blooded prey, and a complete absence of venom, relying instead entirely on muscular strength. This is a textbook example of convergent evolution, unrelated lineages independently arriving at similar solutions because they face similar ecological pressures. One key anatomical difference rooted in this separate ancestry is reproduction. Anacondas, like all boas, are ovoviviparous. They give birth to live young rather than laying eggs, with the eggs developing and hatching inside the mother's body. Pythons, by contrast, are oviparous. They lay eggs externally, and in a remarkable display of parental care rare among reptiles, many python species actively incubate their eggs by coiling around the clutch and generating heat through small rhythmic muscle contractions. The question of which snake is truly bigger depends entirely on which measurement matters most to you, and this is where the comparison becomes genuinely fascinating from a scientific perspective. The reticulated python holds the undisputed record for the longest snake species in the world. Verified specimens have measured over 6.95 meters in length, and unverified historical reports claim individuals approaching or exceeding 10 meters. Though such extreme claims are treated with considerable scientific skepticism due to the difficulty of accurately measuring large wild snakes. The reticulated python's body, however, is comparatively slender relative to its extreme length, built for a more elongated serpentine profile that allows it to move with impressive agility through trees and across the forest floor. The green anaconda takes the opposite approach, prioritizing mass over maximum length. While green anacondas rarely exceed 6 to 7 meters in length, making them shorter than the largest reticulated pythons, they are dramatically heavier and more massive in girth. A large female green anaconda can weigh well over 95 kilograms, with the most credible scientific records placing the upper limit at around 110 kilograms, though older and unverified historical accounts claim weights considerably higher. Even using only the conservative, scientifically verified figures, this makes the green anaconda, by a substantial margin, the heaviest snake species on Earth, a title it holds regardless of the reticulated python's advantage in maximum length. This size difference is rooted directly in sexual dimorphism, which is dramatically more pronounced in anacondas than in pythons. Female green anacondas are significantly larger than males, in some cases up to 4 to 5 times heavier. Among the most pronounced examples of female-biased sexual size dimorphism found in any snake species on Earth. This pattern is believed to be an adaptation related to reproductive success, as larger females can carry more and larger offspring. In terms of raw body diameter, a large green anaconda can reach a girth comparable to that of a medium-sized adult human's torso, an almost unbelievable thickness for a limbless animal. The reticulated python, while occasionally reaching impressive bulk in exceptionally large individuals, generally maintains a noticeably more streamlined body shape throughout its length, even in the largest recorded specimens. So the honest scientific answer to which snake is bigger is genuinely a matter of definition. The reticulated python is longer, but the green anaconda is heavier and bulkier, making both species legitimate record holders in their respective categories. The anaconda and the python occupy entirely different continents, and their habitat preferences reflect dramatically different ecological strategies shaped by millions of years of separate evolution. Green anacondas are profoundly aquatic animals, arguably more aquatic than almost any other large snake species on Earth. They inhabit slow-moving rivers, swamps, marshes, and seasonally flooded grasslands throughout the Amazon basin, the Orinoco Basin in Venezuela and Colombia, and the Pantanal wetlands of Brazil, Bolivia, and Paraguay. Anacondas spend the overwhelming majority of their lives partially or fully submerged in water, with only their eyes and nostrils positioned high on the skull specifically for this purpose, breaking the surface while they observe their surroundings undetected. This aquatic lifestyle profoundly shapes anaconda behavior. Their massive body weight, which would be a significant disadvantage on land, becomes essentially weightless when buoyed by water, allowing these enormous animals to move with surprising stealth and efficiency through their aquatic environment despite their tremendous bulk. The reticulated python, by contrast, is a far more habitat-flexible species found throughout Southeast Asia, including Indonesia, Malaysia, Thailand, the Philippines, and surrounding regions. Reticulated pythons inhabit rainforests, woodlands, grasslands, and increasingly agricultural and even urban environments, where their adaptability has allowed them to persist remarkably well alongside expanding human populations. Unlike the predominantly aquatic anaconda, reticulated pythons are accomplished climbers as well as capable swimmers, moving fluidly between the forest floor, low vegetation, and tree branches in search of prey. This habitat flexibility extends to the python's tolerance of human-modified landscapes. Reticulated pythons are regularly found in palm oil plantations, rice paddies, and the outskirts of villages and cities across their range, where rodent populations attracted by human agriculture and waste provide an abundant and reliable food source, a level of adaptability to human environments that the far more water-dependent anaconda simply cannot match. Both anacondas and pythons are ambush predators that rely on constriction rather than venom to subdue prey. But the specific details of how each species hunts reflect their different habitats and body plans. The anaconda's hunting strategy is built almost entirely around its aquatic ambush capability. A green anaconda will typically lie motionless in shallow water or partially submerged at the water's edge, relying on stillness and camouflage to remain undetected by approaching prey. When a capybara, deer, caiman, or other animal comes within striking range, often while drinking at the water's edge, the anaconda launches an explosive strike, seizing the prey with its powerful jaws before rapidly wrapping its enormous body around the animal. Once a constriction grip is established, the anaconda's method of killing is now understood by herpetologists to be considerably more sophisticated than simple suffocation. Research using pressure sensors and blood pressure monitoring on prey animals has demonstrated that constrictor snakes, including both anacondas and pythons, kill primarily by cutting off blood circulation rather than by preventing breathing. Each time the prey exhales, the snake tightens its coils, progressively restricting blood flow to vital organs including the brain and heart, leading to circulatory collapse and death within minutes, a more biomechanically efficient killing method than suffocation alone would provide. The reticulated python employs a broadly similar constriction technique, but its hunting style reflects its more varied and flexible habitat use. Reticulated pythons hunt across multiple environments, ambushing prey from concealment in vegetation on the forest floor, striking from low branches onto animals passing below, and occasionally pursuing prey opportunistically when the situation allows. Like many python species, reticulated pythons possess heat-sensing pits along their lips, allowing them to detect the body heat of warm-blooded prey even in complete darkness, a sensory advantage that significantly enhances their effectiveness as ambush predators in dense forest environments where visibility is often poor. Prey size for both species scales dramatically with the size of the individual snake. Large green anacondas have been documented preying on capybaras, the world's largest rodent, as well as deer, caimans, and occasionally jaguars in exceptional circumstances. Large reticulated pythons have been confirmed preying on deer, pigs, and in rare but well-documented cases, have been responsible for fatal attacks on humans, particularly in rural areas of Indonesia where large individuals and human activity overlap. Such human predation events, while genuinely rare relative to the enormous population of both species, are more frequently and reliably documented for reticulated pythons than for anacondas, likely reflecting the python's greater habitat overlap with human settlements. The reproductive biology of anacondas and pythons reveals one of the clearest and most fundamental differences between the boa and python families, a distinction rooted in their separate evolutionary histories spanning tens of millions of years. Green anacondas, like all boyd snakes, are ovoviviparous. Rather than laying eggs, female anacondas retain fertilized eggs within their bodies, where the embryos develop and eventually hatch internally before the mother gives birth to fully formed live young. A single green anaconda litter can contain anywhere from 20 to over 80 young, depending on the size and condition of the mother, with larger and older females typically producing larger litters. Newborn anacondas are unusually independent from birth, measuring approximately 60 to 90 centimeters in length and capable of swimming and hunting small prey almost immediately, receiving no parental care whatsoever after birth. Anaconda mating behavior includes one of the most unusual reproductive phenomena In the reptile world, the formation of breeding balls, in which multiple males, sometimes a dozen or more, will converge on a single receptive female, forming a writhing mass that can persist for several weeks as males compete for mating opportunities. This intense male-male competition, combined with the dramatic size advantage of females, is believed to be a significant driver of the pronounced sexual dimorphism observed in the species. Reticulated pythons, like all true pythons, are oviparous. They lay eggs rather than giving birth to live young. A female reticulated python typically lays between 15 and 80 eggs per clutch, depending on her size and condition, in a hidden location such as a hollow log, dense vegetation, or an abandoned burrow. What follows is one of the most remarkable examples of parental investment found anywhere among reptiles. The female python coils tightly around her clutch of eggs and remains there for the entire incubation period, which typically lasts between 80 and 100 days. During this incubation period, the mother python generates heat through a process called facultative thermogenesis, rapid, rhythmic muscle contractions that can raise her body temperature and consequently the temperature of the eggs beneath her several degrees above the surrounding ambient temperature. This maternal incubation behavior, essentially a reptilian form of brooding more commonly associated with birds, gives python eggs a significantly more stable and favorable incubation environment than they would experience if left unattended, a level of maternal investment entirely absent in the anaconda's live birth reproductive strategy. Both anacondas and pythons face significant pressures from human activity, though the nature and severity of these threats differ considerably between the two groups. The green anaconda is currently classified as a species of least concern by the IUCN, reflecting its relatively wide distribution across the still largely intact wetlands of the Amazon and Orinoco basins. However, this conservation status masks significant regional concerns. Habitat degradation from agricultural expansion, cattle ranching, and infrastructure development across South America poses an increasing threat to anaconda populations in certain regions, particularly where wetland habitats are drained or converted for farming. Anacondas are also hunted in parts of their range for their skin, which is used in the exotic leather trade, and are sometimes killed by local communities out of fear, despite the genuinely low risk anacondas pose to adult humans under normal circumstances. The reticulated python's conservation situation is considerably more complex due to the species' exceptionally high commercial value. Reticulated pythons are the most heavily traded snake species on Earth, both for their skin, which is used extensively in the global leather and fashion industry, and increasingly for the exotic pet trade, where captive bred color and pattern morphs command extremely high prices among reptile enthusiasts. The reticulated python is currently listed under CITES Appendix 2, meaning international trade is regulated but not prohibited, reflecting concerns about the scale of harvest even though the species as a whole is not currently considered globally threatened. A particularly significant conservation and ecological concern, directly relevant to understanding python biology more broadly, involves the Burmese python, a separate species within the same python family. Released or escaped captive Burmese pythons established a breeding population in the Florida Everglades beginning in the 1980s and 1990s. And this invasive population has since had a documented catastrophic impact on native mammal populations throughout the Everglades ecosystem, with researchers recording dramatic declines in rabbits, raccoons, opossums, and other native species in areas where pythons have become established. This situation demonstrates in a real and measurable way just how effective python family constrictors are as predators when introduced into an ecosystem with no evolutionary history of large constrictor snakes, and it illustrates a broader conservation lesson relevant to both anacondas and pythons. Irresponsible exotic pet ownership and release can have consequences that extend far beyond the individual animal, fundamentally altering entire ecosystems. So, after everything we have explored, what is the real difference between an anaconda and a python? The most fundamental answer lies in their separate evolutionary origins. The anaconda is a member of the boa family, native exclusively to the wetlands of South America, giving birth to live young and dominating its aquatic environment through sheer mass and ambush stealth. The python belongs to an entirely different family, native to the forests and grasslands of the Old World across Africa, Asia, and Australia, laying and actively incubating eggs and achieving record-breaking length through a more elongated, climbing-adapted body plan. In the question of size that so often dominates popular discussion, which is genuinely bigger, the honest scientific answer is that both species hold legitimate records. The reticulated python as the longest snake species verified on Earth, and the green anaconda as the heaviest and bulkiest, a title earned through one of the most pronounced examples of sexual size dimorphism found anywhere in the animal kingdom. These are not simply two versions of the same giant snake, as casual observation might suggest. They are two independent evolutionary masterpieces, separated by an ocean, by tens of millions of years, and by an entirely different family tree that arrived through convergent evolution at strikingly similar solutions to the same ancient challenge of becoming the dominant constrictor of their respective worlds. Thank you for watching.